Thank you very much for coming. I'm Sebastian. I'm a director of engineering in the OpenShift group at Red Hat. Diane already told you who she is. She works on community development at Red Hat. And we're here to talk to you about a group of projects that we've created initially at Red Hat, and before that even at CoreOS, called the Operator Framework. And I'll go through a lot of details and also a demo later in the talk. But let's start with first things first. What's an operator? Some of you might know what it is. Some of you might already have started developing some, but we're still going to go over the basics once first. So containers brought awesome simplicity to the development world. It also brought a lot of headaches, but one amazing thing that it brought, at least as a developer, is that earlier on, a few years ago, when I wanted to develop a web application, what I had to do, if it was a regularly complex CRUD app, I would need a database, some caching layer, and just to develop that on my laptop, just to get started, I would have to install, let's say, Postgres, configure Postgres, understand how it works, make sure it works on my laptop, install its dependencies, and so on. Same thing for Redis. Same thing for any kind of software that you had a dependency on. And an amazing thing is that now in the development world, all you have to do if you want to work and focus on your web app and your domain-specific code is to do a Docker pull Postgres, Docker pull Redis, Docker run Postgres, Docker run Redis, and then you're good. You're off. You can start coding. You don't have to do anything anymore. This is a gigantic booster for a huge amount of people who would be even intimidated to just install and to try. That is something that's amazing. But it hasn't completely translated. That promise hasn't completely translated one-to-one to the production environments. Soon as you cross the barrier from development to production, everything changes. You need a whole platform, especially with containers like Kubernetes, to even start running your containers correctly. You can do it differently, but like every single scenario has its own drawbacks and good sides. Kubernetes does something very amazing. It abstracts a lot of this complexity that you have and gives you generic features like deployments, stateful sets. If your application with, let's say, your database that has a volume attached to its dies, the machine on which the pod is scheduled on dies, Kubernetes will reschedule your pod somewhere else and remount the volume somewhere else. And your application will continue to work. These generic features that Kubernetes gives you allow to develop a variety of applications, and again, get a lot of simplicity to get these development patterns. The problem is that most complex applications, most applications with state, most distributed applications require way more custom logic and strategies to be run in production. And most of these strategies are domain-specific. They're different for each software. Scaling Redis is not the same as scaling Postgres, which is not the same as scaling Cassandra. Each of them are different. Each of them have different failure scenarios. Each of them need to be upgraded in different manners. Each of them need to be monitored in different manners, all the above. And that domain-specific knowledge is all in the heads of either operations people or the experts that built the software or consult for the software. But that's it. Other than that, if you want to set it up and run it, you have to learn. So one thing that we want to do is fulfill that promise. Make it just as easy to run software in production as it is to run it as a development environment on your laptop. And in a way where people, they have to know the platform underneath. If you're using Kubernetes, let's not kid ourselves. You're not going to get away with not knowing how it works. But at the very least, you're not going to have to know all the details, all the hard, complex minutiae that can be there. You can focus on your own higher level abstractions, higher level domain-specific code. And that's what happened with the operator pattern. It's a pattern that was coined by CoreOS, I think 2016. And the idea was to say, let's leverage this platform that gives us this generic tool set, that gives us an extendable API. Today with CRDs, there's nothing easier than to extend the Kubernetes API. For an expert. If you're not an expert, it's not easy. And then that's the fun part. And then you run it on top you run that application that you build on top of Kubernetes in containers. You don't install it on the side. You don't provide it a special different way of getting managed. You make sure that it's all at the same place than your other applications will run. And then you write the code that is domain-specific to your app. So for example, if you're writing a Postgres operator, you're going to write code to make sure that you can automatically upgrade from one version to another. Handle a complex failure scenario where a master goes down and a slave needs to be promoted to become a Postgres master. You need to handle things like, how do I scale an application up and down? All of this code can be written inside of that operator, leveraging the Kubernetes APIs, and being also exposed behind, thanks to CRDs, a Kubernetes-like API. And I'm going to show examples of this in a bit, just to make sure that we're a bit more clear on all of that. So that's basically it. If you're building a controller on top of Kubernetes that drives a specific application and makes sure it exposes that application just like a cloud service, and by cloud service I mean something like RDS. When you go to, for example, Amazon and you're requesting for a Postgres database or a MySQL database from RDS, you just do an API call and you get a database back. You barely have to worry about upgrades and all that cycle. That's doable inside of these cloud providers. Operators, that pattern is the goal to bring this to any Kubernetes cluster, whether you're on different cloud providers, in your own data center, wherever. And that's the goal, is that developers still have to do all the complexity that I'm currently talking about. There's no way around it. But at the very least, we can create generic codes to help them do that and deal with that complexity. But once we get to the user, the person that actually wants to deploy a database, they don't have to know that complexity. They only have to know a little bit of Kubernetes API. That's it. And they already know that because they're using the Kubernetes platform. Operators have, since that, kind of exploded. Quite a lot of people want to build operators. A lot of people, a lot of ISVs, a lot of open source developers, and even internally at companies. Like, this is not just for open source software, even if that's a preferred way. This is for closed and open source software. The goal is people don't want to have a human in the loop anymore. So that's what all these projects are building, whether it's on Postgres or for Prometheus or for Couchbase or Giga tracing is another one that's not even on that map. We made a list of this awesome operators repository. That's our current way of exposing operators that exist to the world. We're going to talk about better ways very soon in my demos. But that's a great place to go if you want to see what's out there right now. The quality of these operators varies from operator to operator, of course. So I would consider this repo more for experts, and we're going to see how we can make it easier for non-experts. So that's that. That's what an operator is. Did everybody understand that? Or do I need to clarify something about what an operator is? Nope. All right. So what's the operator framework? Well, I talked to you about the complexity that it is to build such an operator. You're not going to get around having to understand, if you're going to build an operator, you're going to have to understand Kubernetes. You're going to have to understand how to write a Kubernetes controller, how to talk to the Kubernetes API, how to generate all the code that you need to even just get started. And then beyond that, you're going to want to manage all your operators. You're going to want to measure all that. How do you do that? How do you package your operators? How do you distribute them? What we did is a specific set of tools, which are different projects, to try to help answer these questions in a complete open source usual manner where we invite the community to participate. The first piece that I would like to highlight is the operator SDK. That's where you usually start. If you want to write an operator, the operator SDK will help you do a couple of things like building your operator. And by building, I mean generating and scaffolding the code that's needed to generate a Kubernetes controller and talk with the Kubernetes API. It will give you abstractions to more easily talk to the Kubernetes API. It will give you tools to make sure that you can deploy metrics or TLS, or that you are testing your operator the right way, so that you can focus on the business logic. And the business logic in an operator is quite simple. Think about one loop in which you are, and you look at the state of the world. I'm a Postgres, if I'm a, let's say, Postgres container, I'm going to want to have a master running. So my loop is going to be running constantly and checking, is a master currently running? If the master is not running, the loop will start it. That's the way you think about it. If you need to scale it out, the loop will look and decide, how many masters do I have? Oh, only one. Well, looks like we need, and how many read-only replicas do I have? Oh, only 2, but I'm being asked to do 3. And in your loop, you basically reconcile. That's where you explain, hey, this is, I need 3, and you bump the version and you do all the logic that you need to get to 3. I will go more into detail about these pieces tomorrow in the deep dive talk, where we will be building an operator, whereas today it's more about showing off how to use operators. So that's what the SDK gives you. It's not the only way to build an operator. It's just a way that we provide you so that code doesn't get written twice. A lot of code, like for example, testing. Testing is another important thing. If you want to fulfill the promise of automatically upgrading, automatically testing, automatically verifying that everything is running, then you need to have automated tests built in your toolkit and from the get-go. Once you have an operator, let's say, again, Postgres or Redis, you need to run it. You can just start it as a normal Kubernetes application. All these projects are not interlocked tightly. So you can just take your operator, run it as a simple container as you usually do. But once you start having a lot of container operators, things get complicated. Because in the end, an operator is just another app, just like the rest. And you're going to have to manage them. You're going to need an operator for operators. We didn't like that name that much, so we came up with Operator Lifecycle Manager. Whether that describes it better or not, we'll see. But for now, suffice to say that this is the project that's there to install, update, manage all your operators. And that's the thing that I'm going to be demoing in a bit, because you'll see that a lot goes into that. It's Operator Lifecycle Manager handles everything from dependencies from an operator to another, to making sure that an operator doesn't die when it gets uninstalled, things like this. Operator metering is one other piece of the puzzle. That one comes after, I would say. There's a whole talk about it a bit later in the conference on Thursday. But the idea is that once you have all these operators installed and running, you're going to want to measure them. You're going to want to know precisely how much they cost, like as in AWS dollars per operator, or even to go more detailed, if you code the logic, how much does this table in my database currently cost? All of this can be aggregated and then reported on, and you can then create different reports to do showback, chargeback, all these different things. I will not be demoing metering this time, but there's a whole session that demos plenty of it, so you should go. All right, let's do the demo, because that's definitely the way I prefer showing things. All right. So what you see here is an OpenShift cluster. Latest version, this is Kubernetes underneath. And on top, what's the page that I have open right now is one of the pages of the Operator Lifecycle Manager. So before I go there, one thing that I haven't talked about, but I'm previewing, and we will have more and more details coming, is what we call the marketplace. We want a way of having people not just show off their operators in a simple repo like awesome operators, but we want a way to be able to actually use operators straight away and in any OpenShift cluster or cluster that has Kubernetes Marketplace installed. So if you install, the goal is that once you have Operator Lifecycle Manager and Marketplace installed, there will be a central place where the community can push operators and make them appear in these clusters. That provides a channel to make sure that things work, that things are tested, that things are verified, and also it provides a direct way from the developers to the consumers of that operator. The idea here is that this page that I'm currently showing is for the administrator of a cluster. The administrator of a cluster decides what operators a user is allowed to use in their cluster at all, just like you would do with permissions in AWS, or in this case, since it comes from the outside source, a admin will need to decide what versions of operators can run and also in what namespaces certain operators can run. This is what this provides. Once you're in, you are inside of what we call the operator lifecycle manager. And you can see that here I already have one operator that's deployed called etcd, but let's deploy another one first to show how it looks like. So the way that it works to use operator lifecycle manager is that first you need to deploy the operator because you want to provide a certain service to the cluster. etcd is already deployed here, so I'm able to deploy new etcd instances, and we're going to do this in a bit. Prometheus operator is not installed. If I want Prometheus instances, I'm going to have to install that. So what you do is you create a subscription. A subscription is saying, I want to follow this particular version of the Prometheus operator. In our case, we're in the preview channel, and we are starting with a specific subscription. So once I create this, what happens is that the operator starts getting installed. So you can see here that it's installing. It's already installed. That goes quite quickly. You can see if you want to see what happens, you can see it in the install plans. You can see that this is complete. This is OLM deploying and installing the Prometheus operator. Once we go now to cluster service version, we can see that it's still waiting because there's some pods still deploying. In a minute or so, it'll be all done and enabled just like etcd. So in the meantime, while we wait for the install, let's have a look at etcd. So the fonts, of course, like this, or more. More? Doesn't look as well afterwards. All right, it still looks okay. All right. The idea here is that I can now deploy new instances of etcd. Currently, I don't have any running. So let's create a new instance. I want a cluster. So this is what your end user does, not the developer, but the person that sits inside of the Kubernetes cluster and decides that he needs a new etcd instance. So in this case, I want a size of 3. I want to deploy to the default namespace because you can choose that. Let's choose example as a name, and then which is already here, and then the version. So once I create this, you can see that there's an etcd cluster that's currently being deployed. And this is where it gets interesting. So it's currently the size. This is a panel that is specialized for that operator. There's no special code that's written for that UI. All that UI does is get this from the status that's coming back from each of the operators. So you can, for example, see that right now, only one member of the etcd cluster is currently active, despite probably already having 3 pods up. The others still needed a little bit more time to form a quorum. And we're back. 3 members are up. So this here directly shows me that my cluster now has 3 members ready to serve. If I want to increase, I can do other things. Size is a very generic parameter. Since it's that generic, I can actually go and create a generic form for it, like this one. And so in this case, we're going to just bring our etcd cluster from 3 members to 5, just to show it. You can always see that this is pure Kubernetes, so you don't need to go through these UIs. Everything is available through kubectl. It's all written back to the object. Like you can see that the object currently has updated itself since we're now at 5. So it will update basically the members down here. There we go. We have 4 members now. It'll probably update one more time. We'll be at 5 members. And then that's it. That's how easy it is. Let's see. Are we at 5 members yet? Not yet. Let's wait. 5. Oh, look. Sweet. It's coming. 1 is unready. There we go. It's all done. So this is our etcd cluster. Now, an etcd cluster is not as fun if you don't monitor it. So we still need to wait for the rollout of this one. It'll take 1 more minute. Give me a second.
What version of OpenShift is this?
This is the latest. This is based on 4.0. That's going to come out. This is all doable on OpenShift 3.11. You need to install like this operator lifecycle manager extra on 3.11, but you can do everything that I've just done. There's nothing special. Let's see. So while the install is still waiting, let's see, because the pods are usually already up, so we can already start creating instances. So let's see. Prometheus is coming up. Great. So Prometheus is coming up, and we're going to have, just like before, that thing is ready. It has 2 pods running. It has an example rule. And the cool thing here is that for Prometheus, Prometheus has more than just like launching a single Prometheus instance. What you can actually do, like you can see the Prometheus instance running here right now, but it won't have anything. It's not populated. Now the cool thing is that you can use the Kubernetes API to create a service monitor. A service monitor is an object that's there to watch other services. In this case, we're going to create a service monitor to watch etcd. So let's I'm going to just copy paste it. So. No, I'm not. I'm copy pasting this out. You're not going to have to read this font. So there we go. Sorry. Thank you very much. That's why we're here. We're all in this together. Okay. All right. So in this case, a cluster monitor is another one of these custom resources in which we're saying we want to watch /metrics of the port called client from servers that from any application that match the label etcd and is in the etcd cluster called example. So now I create this. And I've also said in there, if we want to have a quick look again, that we want to scrape the metrics every 10 seconds. Since this is a talk, we want to be fast. Oh, there we go. It's not yelling anymore that it's not ready. All right, let's go. Is it scraping? Let's see. Usually it takes a few. Let's wait a few seconds. It'll come. So while we wait, let's see. Is there something interesting that we can show off? Let's see. Let's see if it's there. Oh, still not. Let's reload. Oh, there they are. Well, so here are all our metrics. So there it is. The etcd metrics are coming in. Let's see something interesting. Let's see the leader changes seen in total. Have I ever changed leaders? So this is not as interesting because this is currently just a counter. Let's fix this real quickly. So we'll rate etcd. And then here, let's say that we want a selector service equal example. And then we want to do this every 1 minute. There we go. So now, well, we haven't had leader changes. It's been fine. We've only increased the size of the quorum. So right now, leader changes are at 0. Let's kill an etcd node, and we'll do 2 demos at once. And yes, now I'm going to increase the font. Here you go. So I'm going to kill the etcd leader. And while it dies, we're going to go see what's happening. So first of all, obviously, the operator is going to do his job. And the operator is going to bring it back up. I think that's the most important thing. Currently, 4 members because the leader died. This is going to come back by itself. As soon as it's back, we're going to go see the graphs and check how it's going. Oh, there we go. Spiked, but not enough yet. There we go. So in this case, the main demo is that we killed it, and it's coming back. There we go. We're back at 5 members. So if that happened during the night, I wouldn't get paged. I think that's pretty cool, because I don't like getting paged. And we can see in the graphs that it spiked here. Why? Well, because it swapped, the leader changed. So that's it. So that's an example. And this service monitor, the interesting thing there is I currently typed it by hand. That's not so cool. So one of the things that tools like the SDK can do for you is generate those automatically. If I know that I'm going to get monitored, I might as well generate it automatically for the user so that when I deploy my new operator, anything that I deploy with that operator gets monitored. Another thing that the lifecycle manager does for you is it takes all of this and it creates dependencies between operators. So you can create complex applications that depend on, let's say, like a web app, a web application that depends on Postgres, that depends on Redis. The operators will get installed thanks to the chain of dependencies. This is quite powerful in the end. So that's another thing that I'd love to demo someday, but right now I wanted to show off the service monitor. All right, that was the demo. Now, how does one get started with the operator framework? Well, first of all, there's the GitHub page, the GitHub Organization Operator Framework. You go there. There's a getting started guide that I've linked to the line. Every single project in there has its own getting started guide that you can use and play with. They're all, as I said, they're loosely coupled, not tightly coupled, so you can use them all independently. You don't need the operator SDK to use the lifecycle manager or to use metering. You also don't need the lifecycle manager to use operator SDK. You're free to build your operators in Java if that's what you want. It's not a problem. But the getting started guide kind of shows everything coming together one after the other, and it's pretty cool. There's an OpenShift SIG, so we meet every month, we get together, we show off operators that we've built, new tools, discuss problems, brainstorm solutions. That's a fun meeting to attend. It's all remote, so anyone in the world can attend once a month. The link is right there as well. And then there's a Kubernetes operators channel on Slack to talk all things operators. It's quite active. People respond there all the time. This is not just for the Kubernetes, the operator framework. This is for anybody writing operators. We're interested in any operator. And then there's the Google group that Diane mentioned in the beginning. That's that. So I would encourage you to visit any of these websites. They're fun. You learn a lot. It's great. There's lots more sessions about operators. Tomorrow there's a deep dive. So it's me again, and we're going to be building an operator. So we're going to go through how to use Go and also Ansible. So Go when you want to code, Ansible when you don't want to code, to build an operator and to actually do day 2 operations with Ansible. The other thing is, and we're going to build it end-to-end, publish it, and deploy it in the same cluster that I've just showed you. And then we're going to deploy multiple instances of it and see what we want to do. And then Thursday, there's a keynote by Rob, which is about operators and the state of operators. You should attend that. And then what I mentioned earlier, the metering talk. It goes way more into detail about metering. I mean, I didn't go into detail at all. So it's super fun, and it shows you quite a lot of interesting things about how to think about your organization, about data in your organization, operational data. It's cool. And then there's a workshop for those, some of you might be going. It's sold out, but go knock on the door, who knows. And it's on Friday morning, all morning. So that's it. Thank you very much. Questions? And thank you very much. Yeah. Do you want? Oh.
Can we get the mic on? The traveling mic?
I can just speak loudly.
Yeah, speak loudly.
Okay. So I like the concept. It seems very powerful and necessary, but we are creating resources programmatically, CRDs, replica sets, stateful sets, whatever those may be. In a world with Helm, where Helm releases are supposed to be the definitive source of truth, how does this reconcile?
Yeah. So we actually, just like the operator SDK works with Helm as well. You can take a Helm chart. It's currently a separate project. We're currently integrating it. But you can take a Helm chart, and I'm currently talking Helm v2. When you go in Helm v3, there's a lot of brainstorming that needs to happen. But in Helm v2 land, you take the Helm charts and you can generate an operator from it. And then you have an operator running, and you don't need tiller. You can use your normal CRDs to start deploying instances of these apps. That's where it integrates.
Yeah, more around if I were to show a Helm release, and the Helm release should be telling me every resource that's running on behalf of that release. Some of them are kind of hidden, right? Any that the operator created programmatically wouldn't be directly seen when I ask the Helm release what's running.
So I don't have an answer to asking Helm to see that. What I do know is that what we're putting a lot of emphasis on is making sure that operators track their resource, annotate their resources to make sure that you know that everything that's created by an operator belongs to it, and they can also clean it up easily. Like, that would be my answer.
Okay, thank you.
Sure.
Hi. So the service monitor, right? It's just the config which you put in the Prometheus to scrape data, right?
Correct.
So is it like custom to OpenShift or?
No, it's not custom to OpenShift. It's custom to the Prometheus operator. So the Prometheus operator has a CRD that describes how you can tell it to scrape data. and that's it.
So there's one way of doing that thing.
Yes, and that's not specific to OpenShift. That works on any single Kubernetes cluster out there. None of this is specific to OpenShift.
Got it. Thank you.
I just like the UI. It looks really cool, so that's why I'm showing it off.
At Lyft, we have been using a lot of the operator SDK, and we've followed it for the last 6 months.
Cool.
We should be open sourcing some of our operators soon.
Awesome.
But recently, we've seen some development in controller runtime, and then a couple other projects from, I think, Google. How is this ecosystem going to develop or continue to develop? And how is the relationship between controller runtime and operator SDK specifically?
Yeah. That's a great question. So Operator SDK uses controller runtime. It started out doing its own implementation, but there's not much point in having various implementations of that what I call lower level library. So we use the same controller runtime library and try to differentiate ourselves by what we're building on top. That's it. And then, yeah, there's a lot of different ways of building operators. You can use client Go directly as well, like it goes.
Yeah, so I take it that there's continued investment in operator SDK. That's the thing that we were not very clear about.
Oh, yeah.
That's it. Okay.
Yeah, we're participating and we're contributing to a controller runtime. It goes both ways. Like, yeah.
So I have a question about your operator lifecycle manager.
Sure.
So you have an example to build the Memcache operator, I think.
Yes.
And you can easily do the CSV part of it. But can you also add documentation how to build the channels, how to create a catalog? I don't think those things are clear from your project.
If there's documentation that's missing, please, I'll try to remember this. Otherwise, create an issue and it'll get addressed.
Okay.
Or come help. We PRs are welcome as well. Anything is good.
All right. Thanks.
But we'll get to it.
Anyone else?
There was a question here, or there's a couple in the front.
Here. Who was the hand here? There you go. Let's do that one.
Can you give some pro cons on building an operator with the SDK and building it just with client Go?
Sure. I like to respond to that question is, if you want to use client Go and you're an expert, go ahead, right? You're an expert. You're great. But, yeah.
We built an operator with client Go before the operator SDK came out.
Yeah.
And we're wondering, is this worth a rewrite? Is this would it be quick because the SDK is so awesome?
So where I'm going with this is, yeah, you can write it with client Go, but the whole goal of the SDK is to have common code that we share between all the operators. So if somebody finds a bug somewhere, it gets fixed, and it's fixed for everyone, and not just for a few people. And mainly also not to rewrite. There's a lot of common code that gets written beyond your basic interaction with, interacting with Kubernetes is just one little aspect of an operator, right? You have all the rest that you want to be doing, tools to help testing, tools to help versioning, packaging, distributing. It's to simplify these things too, right? And also libraries, to not have to rewrite how to handle TLS again, how to handle metrics, like I said, generating your service monitors automatically. These are the things that we're putting in the SDK because we want higher level tools. Again, you might need it, you might not.
So I have a similar question, does the operator SDK separate the developer from the user in the sense that will the user who is using it, he's basically just taking your YAML and the image binary and basically deploying it, right? Does he need to care about, how does the upgrade cycle for the operator work? Mm-hmm. Does he need to rebase when the Kubernetes gets upgraded? Does he need to rebase his code, or do we still expect an expert who is good at CRDs and controller runtime to be able to do that?
So the user of the operator doesn't have to do anything, because the user of the operator is just a consumer and can use OLM to make sure to step through stable and good versions of the operator. As the implementer of an operator, there I have to use tools to upgrade my libraries, my functions. In the operator SDK, we're going to put stuff to help migrate from one version to another, or even automatically migrate from a version to another.
Right, so that separation we need to still expect, that we can't give the operator to an application developer and expect him to keep upgrading the operator, right?
The developer who's going to work on the operator is going to have to use the tools at their disposal to do that.
Okay.
The SDK will help with it.
Got it.
That's-
And do you know if a single operator like rebased with certain API machinery and controller runtime, is it expected that it will work with several versions of Kubernetes, or that will break?
That's a great question. I should have mentioned this a bit. Our goal with OLM, Operator Lifecycle Manager, and even SDK is to help with that, to not depend on other people's other versions, but more to do automatic probing of APIs. Is API X present? Yes, I can run here. Is it not present? I can't run here. That's what we want to do with Operator Lifecycle Manager, and when you describe what kind of APIs your operator uses. I think that's the way forward, because everything we've done in the past with looking at version numbers and depending on 1,000 different versions just doesn't cut it. The graph becomes unusable.
There's
All right.
another question over there.
One more question.
That might be the last question.
Yeah,
Because
we're done.
I'm not sure if there's another session in here or not, but
Yeah, I just had a quick question about this versus kind of the meta controller. I'm kind of reading this as like the meta controller is fine, but it doesn't perform nearly at the same level, right? Like I'm looking at the operator SDK is something where I would use that to build a more efficient Go controller versus meta controller is like I really just need to do some simple things every once in a while. Am I reading that right?
No, I mean, yes, but the way I would express it is our goal with the SDK, like there's a lot of alternative implementations, but our goal with the SDK is to make what's easiest for the builder of the operator. So we're not going to give 1,000 options to do one thing. We're going to make sure that we have good defaults, that these defaults work, and that's our primary focus. And so make it sure that it's as easy as a Docker pull or a Docker run to use an operator, and also later to develop an operator, right? Like that's the goal.
all right.
I think
Come to the deep dive
Yes,
and
come
join the
tomorrow.
Google group, and let us know if you've built an operator, and we'll make you talk about it.
And come ask me questions outside if you want.